Okay, here we'll talk about next one. Okay, I promise this one will be very short. Okay, don't be afraid. We will talk about fermentation. Yes, we briefly talked about fermentation or anaerobic respiration last time in the long lecture, the cellular respiration. We will. It's like a brief review here. So fermentation. Fermentation is basically anaerobic respiration. Oops. Oh yeah. That's why it will occur when oxygen is not available. And then animal cell will convert pyruvate into lactate. Again, lactate is, you may call it lactic acid. You may assume they're the same thing. Okay, make your life easier. You may assume they're the same thing. Other organisms like yeast, they convert pyruvate into alcohol and carbon dioxide. That's how we make beer and wine, and that's how we make bread and cheese. This carbon dioxide will raise the bread. And fermentation regenerate NAD plus so that can keep glycolysis going. What does it mean? Glycolysis one of the product of glycolysis, remember, is NADH. So fermentation regenerate NAD so that NAD can go back to glycolysis to become NADH. Yeah, to carry a high energy electron from glycolysis. So what's the advantage and disadvantage? Advantage is that it provides ATP, rapid ATP. So when you need ATP, they can give you ATP. But it is only 2 ATP. Yes, you only get 2 ATP, low, meaning 2 ATP. Another advantage is that when you don't have too much oxygen, you can still have ATP. It keeps you alive, kind of. But the disadvantage is that lactate or lactic acid is toxic to the muscle. Lower the pH, meaning that lactate is lactic acid. Acid is the lowering pH of your muscle, and most importantly, is one of the causes for fatigue. So remember, fermentation is very similar to glycolysis in that the input molecule is 1 glucose. Okay, as I said, you need to invest 2 ATP first. Output, what do you get? You get lactate or 2 lactic acid molecule, or if you are animal will give you 2 lactic acid. For yeast or plant, they will give you 2 alcohol or 2 carbon dioxide, and then you have a net. You make 4 ATP. So 4 minus 2, total you'll get 2 ATP as the net gain. So fermentation is very similar to glycolysis in this way. So glycolysis happen, regarding whether or not you have oxygen, and then they said that fermentation follow because in glycolysis you make pyruvate as the output molecule here, but then pyruvate, what happened is that during the fermentation or anaerobic respiration, the NADH will give the high energy electron to pyruvate. So that pyruvate will transform into lactic acid if it is in the animal. If it is in the yeast, you become alcohol and carbon dioxide. So the reason it occurs, remember at the end of the electron transport chain, the last cytochrome or the last carrier is called cytochrome oxidase. What's the function of the cytochrome oxidase? Do you remember? It combines the oxygen gas with hydrogen ion, and then it forms water. So if you do not have enough oxygen gas at the end of the electron transport chain, so that cytochrome oxidase cannot form water, then guess what happened? Everything will reverse. Remember, I said that the electron, the high energy electron is passed from carrier number 1 or cytochrome number 1 to cytochrome number 2. Cytochrome number 2 give the electron to cytochrome number 3, so on and so forth. So if cytochrome oxidase, the last cytochrome or the last carrier, do not have oxygen to form water, cytochrome oxidase will pass the high energy electron all the way back to NAD plus, so the NAD plus reform to become NADH. And then NADH will go back to glycolysis and give out the high energy electron to pyruvate. So that when pyruvate get the electron, pyruvate can be converted into lactic acid or alcohol carbon dioxide. By giving out the high energy electron to pyruvate, then NADH can reform to become NAD. When it becomes NAD, then you can go back to glycolysis to make sure the glycolysis can continue. So what do we use fermentation? Well, I hope you know. Okay, make cheese. Okay, good stuff. Okay, more cheese, yogurt, and soy sauce. Okay, soy sauce if you are Asian. Wine and beer, good stuff. Well, nail polish remover and rubbing alcohol. Well, that I don't know, but since it is on the slides, I assume it is correct. Make vinegar, okay. Okay, the last part is the compare and contrast between photosynthesis and cellular respiration. It is pretty nice. Professor Memovich did a very good job here. Both plant and animal cell do cellular respiration. Okay, I would like to put a word living. Okay, living, only living cell. Both living plant cell and living animal cell do cellular respiration. Only living plant cell do photosynthesis. Photosynthesis. This is S. Okay. Okay, both processes utilize electron transport chain and chemiosmosis. Chemiosmosis for ATP production, correct. This is correct. And then photosynthesis reduces carbon dioxide to become carbohydrate. Yes, reduces is a good term because carbon dioxide gain hydrogen to become carbohydrate and release oxygen. Yes. Respiration utilize oxygen. This is interesting. And give off carbon dioxide. Utilize oxygen. Oxygen combines with hydrogen ion to form water. So you can call this reduces. Yes. You can also call this reduces. Oxygen is reduced because oxygen combined with hydrogen ion to become water. So you can use the word reduces here. Remember oxidation and reduction, the definition of oxidation reduction. So you can utilize, it is more neutral, but it is not scientific. If you want to be scientific, you can use the word reduce here. So this is the summary of the two photosynthesis and respiration compared. You can see that they are exactly opposite, okay? Thylakoid take water, it split the water to form oxygen. Christid takes the oxygen combined with hydrogen ion to form water. And then in the stroma, you see that carbon dioxide becomes this sugar, precursor sugar. Carbon dioxide get reduced to become carbohydrate. Yes, carbon dioxide get reduced. And then carbohydrate is get oxidized to become carbon dioxide. And this is also different. Stroma uses the NADPH to become NADP, but matrix forms NAD, use NAD plus to form NADH. Matrix, this part they refer to the Krebs cycle here. So you can see that it is opposite. This is totally opposite, the two reaction.